Good morning. It's great to see you all today. Greetings to everyone joining us as well via our EPN YouTube live stream. My name is Eric Toman. I'm the interim director of Ohio State School of Environment and Natural Resources. March is a very exciting time for the EPN. For at least the past 7 years, we have partnered with the Water Management Association of Ohio, pronounced WAMO, an acronym form, and their affiliated Terraqua student organization to host 7 March EPN breakfasts in a row, including during those crazy 2020 and 2021 years. This year, a few other organizations joined our planning efforts, including the Ohio Stormwater Association, the Friends of the Lower Olentangy Watershed, and both the Bird Polar and the Climate Research Center and the Ohio Water Resources Center located here at Ohio State. Ohio State has many water-related assets and faculty, staff, and students conducting water research within Ohio and across the globe. A group of water researchers from across the university has recognized the whole as greater than the sum of the parts and worked together to build a water-based web platform, Water, at Ohio State. This site brings together the university's water assets, people, tools, and other organizational resources into a single online location so that faculty, students, and external partners and other stakeholders can have better access, awareness, and alignment when it comes to water-related activities. I'm informed that the planned launch of the Water at Ohio State website is World Water Day, which is March 22nd. Linda Weaver's and John Leonard's team at Ohio Water Resources Center will be here at various times today and can explain this new resource further. The postcards at your table have the web address for when the site goes live as well. One of the goals of this website is to improve coordination within the university when responding to water-related opportunity or crises. It's hard to believe how a small community in eastern Ohio can turn into the international center of a major environmental crisis overnight, as we've seen with the recent train derailment. I know members of our community have been using the high-quality resources published by the Ohio Water Resources Center in recent weeks, which have offered scientific grounding to understand and respond to the situation. Our hearts go out to our neighbors in the Upper Ohio River Valley as they work together and with national and regional leaders, as well as I imagine some of the folks in this very room here and online now to more positively move forward in this long process of recovery. A few individuals who worked with the EPN to organize today's activities are Lara Fay, Eugene Brigg, Cindy Brooks, and Craig Smith, who was also operating the registration table out front. Melissa Menere, Kari Mackenbach, and Chris Yoder, each of whom you will be hearing from later today, played a major role in structuring today's multifaceted session as well. And a final thanks to Karina Pegau for arranging speakers and teaching the EPN about the term eco-hydroclimatology. You might not yet know what eco-hydroclimatology is now, but by the end of this event, you might have a passing grade's worth of an understanding. Hope we all do. Here in the room, there's a QR code located at your table that will take you to the online digital brochure for this session. For those watching via YouTube, please see the link that Molly Bean is dropping into the chat now for this brochure. The brochure contains information about each of our speakers, including their professional bios. We have arranged for our programs to be zero waste events, so please follow the signs posted at the various trash, recycling, and composting bins located in this room and in the hallway area. We realize the plastic utensils in use today are not compostable, and we're still working with our catering services to provide compostable utensils on a consistent basis. So thanks for understanding this. Students registered at no cost today, courtesy of Ohio State School of Environment and Natural Resources, and with special support from the sponsors listed in the program. Please take a minute to review today's organizational sponsors. The support and lead up to today from these sponsors and our WAMO co-hosts was tremendous, and we are so grateful for their support. These sponsorships allow us to offer no-cost participation to students. They also allow us to connect with a wider and live audience through virtual formats. There are some students here in the audience who I want to quickly acknowledge for their leadership roles at Ohio State. Ariana McGuire, Troy Keller, and 2 SENR majors, Mia Rankin and Earth Science major, who are respectively the president, treasurer, and vice president of Terraqua. Terraqua is a student organization that focuses on water resources, professional development, and hands-on experiences that will aid students in their future professional endeavors, such as internships, environmental careers, and graduate school. Terrestrial, with support from their faculty lead, Eugene Brigg, host knowledge-sharing events with environmental professionals. They have facilitated fish and macroinvertebrate water sampling activities for students. And in the spring semester, they work with Hidden Lake to get students certified in data collection, water data collection. Please contact Ariana, Troy, Mia, and Eugene to learn more. Now, if you can raise your hands, so people can see who you are. Thank you. Thank you. On a related topic, the deadline for the Ohio EPA Scholarship Program, which provides scholarships up to $5,000 for rising seniors, is due by April 17th. The Ohio EPA Scholarship is for undergraduate students in the environmental science and engineering fields. There's more information on your tables, and Carolyn Watkins is here as well. Thank you, Carolyn, to answer any questions that you might have. The agenda located in your program will give you a flavor of the robust and important topics that we will be exploring today, which bridges the environmental science and engineering fields. Over the next hour and beyond, you will learn about atmospheric changes regionally and how these factors interact with terrestrial changes, including the role of impervious surfaces in impacting Ohio's water cycle. Today's first speaker, Dr. Jim Stagge, will outline the broad themes for today's program. A reminder that our program brochure features the complete bios for each of our presenters, including Dr. Stagge. Dr. Laura Johnson, due to an unplanned situation, will be presenting virtually. She's doing fine, and we're so grateful she's made it work to join today virtually from Tiffin. I also understand that Doug Kane is in the audience here today, ready to jump in the event that technology does not cooperate with us. So, Doug, I guess you're on notice. For those on YouTube, please feel free to utilize the chat function to post your comments, thoughts, and questions throughout this morning's program. Our team will be reviewing those questions, and we will also take questions from the in-person audience after 9:15 a.m. this morning. And with that, I'll welcome up Jim to get us kicked off.
Good morning. Hi, everyone. It's great to see so many people out here, particularly this early in the morning. Sorry, I'm screaming. As we talked about, I'm just going to give a very broad, very quick, so not super detailed, look at some of the issues that are facing Ohio with respect to a changing hydroclimate. So as we get into some of the issues that we're facing, basically the way I like to frame this is to say the concern with a changing climate is that what previously may have seemed unlikely or extreme under a changing climate may become more typical. And that leads to potential impacts to infrastructure that was designed in the past, and potentially to ecology, which has evolved over an even longer period of time in this region. And depending on the resilience or the vulnerability of these two things, a changing climate or changing hydroclimate could induce larger impacts. And so what I'm going to be telling today is a little bit about what we've seen in the research. We're seeing a consistent story moving down from kind of our large driver, precipitation, in through our hydrologic cycle, and also I'm going to end with a little talk about temperature and water temperature. So on a broad scale, what we're seeing for Ohio and a large portion of the Midwest is a general increase in annual precipitation that's been occurring over the last century. But in particular, it has intensified since about 1970, 1980. These are two kind of early summer and late summer maps, but you can see here, everywhere in blue, we've increased seasonal precipitation. And the view on an annual scale is even more drastic. But you see Ohio is one of the bluer areas, even within the Midwest. In particular, as we start to look at seasons, most of this intensification is happening in the winter and spring seasons. And we'll talk about what's going on in the summer, particularly late summer, in a moment here. If we zoom in on, for example, one of the longer gauges that we have in Ohio, Marysville, which is just west of Columbus. And we break down the seasonal precipitation. So this is December, January, February, March, April, May. So moving in 3-month seasons across. What we see is, again, this sort of pause in the 1960s, 1970s before a rapid intensification of precipitation. And in this case, in Marysville, maybe most in the kind of early spring, this March, April, May season. But this is very typical of most of the gauges that we're looking at within the state of Ohio. If we zoom out even further to look at this kind of at a national scale and situate us spatially, so this is research by Kay Sung, who I think is somewhere in the room, that hopefully should be published very soon. But we're looking at, so this is again our spring season, and we're comparing the more or less modern period, 2010, versus what we consider pre-industrial, so before really the large impacts of climate change took hold. And then into the future, so looking at 2100 under an intense climate change, we see that Ohio and the Midwest in particular are getting significantly wetter, that we've already gotten significantly wetter, and it's only projected to intensify over time. So this is something that we need to keep in mind as we start looking at our hydroclimate system. We can also step even farther back. Again, more work, shameless plug, myself and Dr. Sung. So this is zooming even farther out into the long historical record using tree ring reconstructions. So this gives us the opportunity to look roughly 1,000 years into the past and situate ourselves. So this first line, this first dotted line is 1900. And the second dotted line is where we are in the present. So what we're seeing here, and this is for the Ohio River Basin in the winter, is that our 1900s was more or less one of the drier periods, the early 1900s, but since then we've not only intensified, but we've intensified beyond the point where we were even 1,000 years ago. So we're entering an era that is outside of the pre-industrial conditions. And again, that is only projected to intensify with climate change over the next century. So that's kind of the farther to the right. And we've got two emission scenarios, kind of a high emissions and a low emission scenario, but both, again, well outside of the pre-industrial conditions. Zooming in, sorry, this is all doom and gloom, but zooming in a little bit more, talking about precipitation extremes, which is really what impacts a lot of hydrology. If we look at the intensity and frequency of very wet days, so above sort of the 90th percentile. Again, Ohio and the Midwest stands out both in terms of increases in frequency of very wet days and intensity in very wet days. In fact, we're one of the few areas that really pops. And obviously the West has been getting drier. This is historical. We can also look into the future with these extremes, and I think Aaron might talk a bit about that. But again, very similar story. Over time, we have this kind of flat or lull in the mid-century, after which we've seen this gradual increase towards the present. And again, our models and our observations coming together. When we look into the future with our best climate change models, again, we see this bullseye centered right on the state of Ohio in terms of precipitation extremes. This is, again, for the highest, it's always most extreme. When you show the most extreme emission scenario, right, that obviously shows the highest pop, but this is the worst case scenario, and we see Ohio right in the crosshairs of this, looking at the 20-year storm event So what previously we'd see once every 20 years on average, we're projected to see that about every 4 to 5 years. So a drastic increase in the frequency of these large events. And we see a similar story as we draw down into the hydrology. So for example, mean annual flow increase, looking at, so these are near natural streams, so with relatively little human influence. And we see again this bright blue area in the Midwest and particularly centered on the state of Ohio. So we're seeing more increases in precipitation, which seems to be filtering its way down into increases in mean annual flow. Likewise, when we zoom in on floods, so the high end of our flows, we're seeing increases in both the magnitude and the frequency in large flows. So again, we're starting to see a consistent picture here in terms of our hydroclimate system. Again, we can talk about all of these things in more detail. I'm giving you the absolute thumbnail view. This is from some recent research that I've been working on at a relatively long gauge site here in Ohio. And we see again, this is winter, so these are daily increases, and we see a consistent trend. So in this case, blue represents the 1950s, and we see a trend towards larger single-day increases in flow at this gauge. So again, all of these things coming together. The one thing that I haven't mentioned is summer, because actually the picture is a little more muddled for summer hydrologic response. We think that we're seeing relatively flat precipitation, but increased evapotranspiration because of increased temperature, which drives down soil moisture. And so in all of our climate change runs, so this is a future climate change run for the Yoder River, we see major increases from the blue historical to the red modeled during the winter and the spring, as we've been talking about, but an ever so slight decrease in flow during the summer. And that corresponds with our increased temperature and evapotranspiration removing water from the system. Complicating all of this is the impacts of land cover change. So Ohio is interesting. We've got a long historical record of increases in developed area and forested area at the expense of agricultural land and wetlands, so the two lower rows here. And viewed spatially, you can see major, well, maybe you can't see, but major increases in both forested area and urban areas, shown in red, again at the expense of agricultural land. And try as we might with our best stormwater conservation measures, this likely has an impact on our hydrologic response. And the last thing I want to talk about before I get off the stage here is a little bit about temperature. So again, we have seen a long-term trend towards higher temperatures, again, most pronounced after the 1970s, 1980s. And the largest trend that we see is in daily minimum temperatures. So our maximum is oftentimes limited physically or due to thermodynamics, but our minimums have been dramatically increasing. Viewed spatially, here again, red being warmer, we see Ohio right in the crosshairs. This is for early summer, late summer, or early growing season, late growing season. And all of this works out to be a little bit of a complicated story in terms of the water temperature that we're still trying to figure out. And so I'll especially based on time, I think I should leave it here. We are seeing some responses to the ambient temperature, but that's hard to piece out. What we see more clearly is how urbanization is affecting our receiving water temperatures. So parking lots are the largest culprit. This is work by my colleague, Ryan Winston, here at OSU. So he's got temperature sensors at several sites within Ohio, and he's seeing large increases in runoff temperature. And our stormwater control measures, things like detention ponds or infiltration, kind of have mixed effects. So those ponds tend to, in many cases, increase temperature because the water is sitting there, whereas our infiltration and storage measures are decreasing temperature. And with that, I should probably get off the stage. I could talk all day, but I should probably let, I think Laura is next. And so I will thank you all, and we'll be back up here for the discussion.
Okay, so it's a little quiet on my end, so I'm going to assume that you're ready for me to go and that you all can see my slides. Awesome, great. Okay, there we go. And let me get myself out of this picture. Perfect. Okay. So, hi everyone. Thank you for pairing with me today. As you can probably tell, I'm a little under the weather, so I'm hoping my voice will last for this entire very short presentation. With that wonderful background on how climate change is going to be affecting hydrology in this region, what I wanted to really do is talk about how we approach monitoring stormwater and why we do things the way we do them, and then sort of, basically hammer down on some of the trends that we just saw. So at Heidelberg, we have a long-running tributary loading program where we've been monitoring streams and rivers all around the state of Ohio. You can also see up in Michigan as well at the River Raisin. And we've been doing this for quite some time. Our goal of our program is really that we want to quantify the loads. You can also think of that as the mass of different contaminants, particularly nutrients and sediments, coming from these watersheds. And with the type of coverage we have, we drain a lot of different land uses. That being said, most of our watersheds are draining an awful lot of agriculture. We only have a handful that are focused more on urban. But places like the Great Miami and the Scioto, of course, are downstream of large urban areas. We are currently monitoring from 23 locations, and you can see on this map that I basically scaled it based off the color of the marker, based off of how old the stations are. Our Maumee and Sandusky stations were started in 1974, but our more recent additions that you can see in white are smaller watersheds, because we're trying to set up these baselines to be able to understand what practices are going to be effective at reducing different nutrient loads. Each one of these stations where we're collecting water samples are paired with USGS gauges, so they're doing the water quantity and we're getting the water quality. And so if you went to any one of these stations, it would look something like this. I'm going to see if I can move my thing. No, I can't. So basically, we have a building that's beside the river, and you can see that there's a pump that's pumping water into that building. We use an automated sampler to collect 3 samples a day. We analyze between 1 and 3, depending on storm flow conditions. At this moment, most of our stations also have a sensor in them that's collecting samples every 30 minutes. So basically for turbidity and conductivity, pH, temperature, those types of things. At a couple of our stations, we're playing around with some automated colorimetry out in the field so we can get real-time phosphorus and nitrate data. Those have been a little bit tricky, and we mostly just do those during the spring and summer. But for a vast majority of our stations, we physically go and collect the samples from the auto samplers every week and bring them back into the lab for analysis of various nutrients, anions, and suspended sediments. Okay, so why do we need this approach? This is pretty intensive sampling. We're collecting a lot of samples, usually somewhere between 400 and 500 per station per year, with a higher frequency when it's really annoying to have to try and filter and analyze samples. And we do it, and hopefully this picture in the background of the Sandusky River is telling you why, is because a lot of times storm flows happen very rapidly, and that's when everything moves, especially when we're thinking about loads. And so this is just a hydrograph, an example hydrograph from 2015. It was an especially wet spring and summer on the Sandusky River, and you can see a series of very large storm events. The storm events all happened fairly quickly. They were done within, probably a week, that peak of the hydrograph. I'm going to see if I can, hopefully you can see my pointer here is probably over a day or two. And what's important about this, I want to point out, is that each one of these peaks in the storms were various sizes. Sometimes there were some really little storms. Sometimes there were some very large storms like the middle of June. Okay, so these storms can happen rapidly, and sometimes it can be hard to know whether you're really going to get that precipitation event and if it's the perfect conditions like we have had over the past week or so where the ground is wet enough to generate a lot of runoff. But also, when we look at the actual water pollution that comes from this runoff, it can be really variable too. So this is showing that same set of storm events, but now with phosphorus, nitrate, and atrazine, and you can see that for each of these, they each respond differently to the different storm events, and they respond differently, to the different storm events themselves. So we have two different things going on here. So for example, for dissolved phosphorus, we tend to see that dissolved phosphorus increases with pretty much any storm event. It varies a little bit depending on them, but with these really big ones, we're always going to see an increase. Whereas nitrate, we only saw an increase with that storm event in June, which was fairly minor compared to the rest of the other peak flows. For atrazine, we actually had an early peak here for a very, very minor storm event that you probably wouldn't have even thought would have generated a whole lot of runoff in the first place. And so a lot of these things vary depending upon how they interact with soil, but then also when they're applied. But on top of that, the way that water pollution can respond to storms will also vary by river. So this is showing a much larger view here. So this is our about 10 years worth of dissolved phosphorus concentration data. This is just the raw data, nothing exciting here. Each line is the start of a new water year. And you can see the Maumee River on top varies a lot, right? So you see a lot of variability associated with the storm events. We see variability that happens seasonally, where in the winter and spring, we have slightly higher concentrations. When we get into late summer, we get down to very low concentrations sometimes. But then the Blanchard River, which is a sub-watershed to the Maumee, we can see slightly different patterns here. First of all, the concentrations are way higher. You can see our scale goes up to 1.2 instead of 0.4. So that's always important to notice your scale. But then what we see is that you get these really big peaks and concentrations in late summer when flows are really low. And that's happening because we happen to be near the effluent of Finley's wastewater treatment plant. So we're having a combination of factors here of both the effluents coming in. When it goes into a smaller river, we get higher concentrations along this baseline of highly variable responses to storm events, similar to what we see up in the Maumee. So what I just said is that we collect a lot of samples because not only do we see that the things we want to measure in water vary by storm, by what we're measuring, but it also varies by river. And sometimes it's hard to predict exactly the scale of those responses. So how has stream flow changed over time? And you just saw a little bit of that, and I'm going to just re-hammer this point. And I think you know what the gist is going to be. We've seen these increases in total precipitation and increases in heavy precipitation events already. And so we would expect that could influence our hydrology. And indeed it has. I just randomly picked the Cuyahoga, the Maumee, and the Scioto because Cuyahoga is near Cleveland, Maumee goes in the Western Lake Erie Basin, and the Scioto is where you guys are. These are all showing increases over the past 50 years in terms of annual stream flow. So even with these potential drier summers, we're still seeing an cumulative effect of increasing stream flow on these rivers. I will note there's a lot of variability here. Of course, we get a lot of variability from one year to the next, but the main point here is that we are starting to see these increases over a period of record. But the real way to assess some of these real impacts is thinking about flashiness, which I'll remind you all is the frequency and rapidity at which stream flow changes. So this is a great example of the Portage River and the El Salvo River. the Portage being the one that's really peaky here in the background with the slightly thinner lines. You can see the Portage River has much lower base flow, even though these are similar sized watersheds, but much higher peaks, whereas the Au Sable here has very small responses to these storm events, but tends to have a very consistent base flow. Part of this is because of their regions that are different, but then also the Portage River has a lot of other human impacts that are influencing its runoff. And so back in the early 2000s at our lab, we developed the Richard Baker's Index, or the RB Index, to be able to quantify this flashiness. And this is basically looking at the ratio of the change in stream flow from one day to the next. So you literally take the difference between those two and you divide it by the total stream flow for the year. So I put the equation there because it always looks impressive, but it's really a simple equation. The ratio of one basically saying that over a year, you could have as much change in stream flow from one day to the next as the total amount of stream flow for that year. That would be hugely flashy. Fairly rare to see anything quite that flashy. The things to know about flashiness is that it changes for some physical characteristics and some general reasons, right? One of them being with watershed area. We can see flashiness go from being really high when you have a really small watershed to being to being much lower when you have a larger watershed, which makes sense. Because the smaller watersheds, you can see the effects of that precipitation, whereas in larger watersheds, you have to have all of these different inputs coming in to make a change. But we also see these changes with ecoregions. This is a map showing ecoregions in the area with the higher flashiness being in the black spots and the lower being white. And you can see the eastern, like most of these corn belts, eastern to all the way to the western corn belt plains, tend to have higher flashiness than when you get up into the hardwood forest and driftless plains. So there's ecoregional differences too. But in general, I wanted to bring us back to our watersheds we were just looking at. We are seeing increases in flashiness across all three of these watersheds. Although clearly this is probably not the best way to look at it, because for the Cuyahoga and the Maumee, you could argue that this is a nonlinear trend and things kind of leveled off once flow got really high. And that's something that we need to continue thinking about, is how increasing flow could affect this flashiness index. So I just wanted to leave you with a few take-home points. The first thing is that if you're sampling for water quality during storm events, it can be a really intense process. But as you can see, hopefully from our data, you get a lot of really important and useful information. The reason you need to sample so intensively is because the response of water quality to storms will vary by the storm, the parameter, and by the river. Annual stream flow discharge and flashiness has increased over the past 50 years, reflecting some of these changes in climate. And for us, when we're thinking about especially non-point source runoff, that's clearly going to have an impact. So what we need to be starting to think about are some innovative solutions to managing that storm runoff, so we can start to buffer that changing climate, whether you're in an agricultural, urban, or you maybe even forested watersheds, they're all going to be influenced. So with that, this is my contact information, and I think I'm all done.
Good morning. I'll introduce myself, I guess. I'm Kari Mackenbach. I'm with MS Consultants. I'm Vice President of Strategic Pursuits, Water. And I guess I picked the right occupation, right? At the end of the day, I think I'm preaching to the choir. We're never going to get back to pre-existing conditions. As Jim said, the 1800s is in the past. So we're not going to be able to fix our watersheds and our sub-watersheds and have any recognition of what it might have been in the past. Next slide. But what are we seeing? I mean, there's all these great scientists are doing all this research and study on water quality and water quantity. And what we're seeing in our natural environment is a change in our land use, a change in our watersheds. So coupled with all of these increased events and these increased issues that we have with water, stormwater, and flooding, We also have a lot more buildings and a lot more conversion of the natural soil to impervious areas. So all of that is impacting how these flood events and these storm events are impacting our communities. Flood events are higher magnitude and they're closer together. I have been a CFM for Certified Floodplain Manager for 23 years, and I have seen a dramatic change in how these storm events are impacting people. I mean, just, direct influence of, well, this storm never happened before, and they're very upset about, this never happened in the 50 years I've lived here. So I think one of the things as the practitioners of and the frontline users of regulations and the tools that we use in our toolbox, there are things that we can do to positively impact these events. I'm a green infrastructure practitioner. I believe in it. I believe that integrated planning and looking at both traditional solutions, we can't use just green infrastructure. It's a great way to optimize your system, but it's not going to be the end-all, be-all solution. We have to look at some hard solutions along with green infrastructure. So it is a way that we are trying to tackle these issues. Next slide. And one of the things that we're doing in the water resource world is we're looking at more advanced modeling. Modeling is really helping us understand these watersheds. A good example is the county adjacent here. The South Fork Licking River has flooded for eons. It was considered a swamp at one time. And so the question is how do we understand how that watershed has changed, and are we able to adapt the way that we develop the land? Right here in the heart of Columbus, we have been installing green infrastructure. I don't want to steal Dante's thunder, but Blueprint Columbus has been around for over a decade, and they have shown impactful uses of green infrastructure. Now, once again, in an urban setting, it's not the end-all, be-all solution, but it is something that we know is impactful, and we're able to use our intelligent scientists here in Ohio State and others to monitor and give us that real value as to what green infrastructure has on the impact of these events. So what we're looking for in the use of green infrastructure, I think we have had a lot of lessons on what works and what doesn't work in certain settings. And so being able to go back and look at that data over time to understand what we should be investing in is important. This helps with not only quantity issues, but also quality issues. And at the end of the day, this is going to help us manage that next storm event, because I believe we're not going to be able to change our hydrology. We're not going to be able to impact the storm events that are coming, at least not to a great degree. So how do we adapt? How do we become more resilient so we can weather the storm and our infrastructure stays in place after that event? So we have to think a little bit outside the box on some of our solutions. I think Jim mentioned the traditional stormwater solutions with the detention basins. It's my arch rival. I cannot stand that technique because it is something that not only is an eyesore, but it doesn't function correctly, and it's just the way that we always have done things. So in order for us to adapt, we have to look outside the box on what solutions make sense. And with that, I will introduce Alicia Silverio. I was quick. There we go. Everyone remember that.
Thank you. So my name is Alicia Silverio, as Kari mentioned, and I work for ODNR's Floodplain Management Program. And in our work at the Floodplain Management Program, we primarily focus on working with communities that participate in the National Flood Insurance Program. Now, we have 753 participating communities across the state and approximately 100 communities that don't. So typically when I'm talking to when I speak to people, I'm talking about regulations, I'm talking about insurance, I'm talking about mapping. But today, I've been asked to talk to you about the people that are affected by flooding. And so you've heard a lot of information, a lot of great data about the impacts of flooding, what we're seeing in climate change, and our discussion will continue today. But one of the things in my position that I have the opportunity to do is to interact with people who are threatened by flooding, who are impacted by flooding, communities that are concerned about flooding, but are struggling to figure out solutions on how to address this flooding, because those communities are often battling immense pressure to develop those areas. And so when they have these flood-prone areas in their community, but they're still under pressure to develop them because they're looking at how do we economically sustain our community, they're faced with tough choices and they're faced with pressures. And so there's a reality of having to make those tough choices. And so what we see challenges with those communities is trying to regulate those areas, trying to implement strategies to positively reduce flood risk. But it's very hard to do because flooding isn't something you see in an area every day almost. And when sometimes, the memory of the flood subsides quickly after the flood. And so the strategies to reduce that flooding become less of a priority for that community or in the residents' mind. And so it becomes very challenging to implement the measures necessary to reduce flooding. The communities are often relying on federal flood hazard mapping, but unfortunately, these maps across the nation only map about 1/3 of the stream miles across the nation, and so that's woefully inadequate in understanding our flood risk. And these maps are often outdated. They're based on various levels of data, some studies from the 70s, and we're regulating according to that today when our built environment has changed so significantly. And when you're making regulatory and development decisions today based on very, very old data, that's going to impact your citizens today. And so it's very hard for communities to make those decisions based on data that they don't have readily available. And I'm glad to see that we have so many institutions and agencies and organizations that are looking more at climate change, and they are producing the data that will go to create the studies that are used to improve that risk mapping so that communities have a depicted risk to help them understand. Because we're also seeing now an increase in pluvial flooding. So that unmapped flood risk, where we're seeing the increase in high-level storm events, where we're seeing that, that urban flooding, that drainage problem that goes up and down quickly, but the impact is still significant to those residents that sustain damage. So the impact to those residents, whether it's, a quick flash flood in or outside of a flood hazard area, is still somewhat the same. They have lost their prized possessions. They've been displaced from their home. They have the stress of dealing with that loss and the impacts of that. And we also see that disproportionately, thank you, that, can never get that word right. Disproportionately, it's affecting lower income populations. We're seeing lower income populations as a general that are inhabiting these low-lying flood-prone areas, and we need to focus efforts on reducing risk to those populations as well as informing them of the risk that exists, because we may not be able to reduce that risk completely or eliminate that risk. So it's important to take those populations into account that may have even a more difficult time recovering from a disaster event. Now, I do want to mention that some of the work that we're doing with the Floodplain Management Program is we are trying to focus more outreach and work with communities that have a high social vulnerability index. So our education and outreach is really trying to be directed at communities that may have less accessibility to some of that information, that may not have community officials with, they may not have a dedicated community floodplain manager. That floodplain manager may be the mayor, who is also doing their best to run the community, but they also found out when they ran for mayor, they were running for floodplain manager and responsible for making sure that all the development in the community is safe and is complying with regulations. So we're trying to help those communities understand how better to reduce risk locally and how to participate in partnerships and engagements where they can look regionally at flooding and what they can do even within their own capabilities. So there's a lot of efforts that are being introduced. Some of this is supported by the presidential administration's new Justice 40 initiative. They're directing funds towards, they're making it a goal toward that all of about 40% of certain federal investments flow to disadvantaged communities that are marginalized, underserved, and overburdened by pollution. And one of the primary groups that is a target of this are communities affected by efforts in communities affected by climate change. So it's a great initiative to see that federal dollars are being directed towards addressing risk in these areas that are socially disadvantaged. So we are going to continue to work with communities to try to help understand their risk better, to communicate that risk better to their residents. One of the challenges is because they are under so much pressure to develop, the adoption of standards to regulate locally that would require that development be protected to a higher level of flood protection are often not attractive. It's not an attractive concept for those communities to consider. They're thinking more in terms of economic development instead of the sustainability of the development that comes into their communities. And so we have to try and change the thinking. We have to try to change how we target populations in our communities and reduce the risk associated with life in those high-risk areas, because it isn't always feasible to consider just removing people from the floodplain. If it were that easy, we would have started doing that a long time ago. And we do continue to try to make those flood-prone areas safer. We encourage communities to do that through mitigation, through opportunities for property owners to participate in buyouts, et cetera. But the fact remains is sometimes, it is just really hard, as Kari mentioned, to change that built environment and to go in and address all of those flood risks through one solution. There's not a one-size-fits-all for every community. And so it takes a lot of funding and a lot of time and effort to understand the unique flood problems within each community and how that's impacting residents. And so we have to keep working to communicate risk better. We have to help the population understand that, these areas are, they are at risk. And even though they might not be able to see that risk on an everyday basis, that the risk is real and it could impact them significantly. And those impacts are long-standing risks. It's very hard for people to recover after these disaster events. Businesses can be impacted significantly. The disaster assistance that is often available is not intended to make anyone whole. It only helps people cover some bare needs. And so flood insurance is often encouraged, but what if you're a property owner, who has a hard time affording flood insurance? That is a hurdle for communities to develop their resiliency and their sustainability. And so, it's important to look at the affordability, and I think that the federal government is starting to look more at the affordability of flood insurance as they go on to address risk and look at reforming the National Flood Insurance Program, but we are seeing it's taking a very long time, and the work begins locally here in Ohio, here in communities, here with our organizations that can help support those communities with data and information, volunteers, and resources to help those people build their communities in a way that is sustainable long-term and helps them recover from impacts of flooding and climate change in the most effective and efficient way possible. So thank you for being here to listen to our message. We are grateful to be a part of the water community with so many knowledgeable and engaged professionals. And I see so many faces in this room that I've worked with over the years that really help connect us with those organizations, those communities, those citizens, and in need, and that we can try to assist. So the opportunities to carry that message forward are here with us in this audience, and I hope we continue to do so, because I think the communities rely on us for the information and helping them know next steps and where to go forward. So thank you for the opportunity today.
I'll just hold this, I guess. Thank you. I appreciate the invite, and I was asked to talk about the concept of biological integrity. And of course, that emanates from the Clean Water Act, as most of you know. So I'm going to not try to get bogged down in too much of the Clean Water Act E's of Section 101 and A and A2 and all that, but I have to, because this is where the Clean Water Act objective is stated, and that's to restore and maintain the chemical, physical, and biological integrity of the nation's waters. That is known as the biological integrity provision of the Clean Water Act. Can everybody hear me okay? Because I really can't get to this speaker, so I apologize, unless I really lean forward. So there's also a subsection of that where it says that it is a national goal that wherever attainable, and I want you to remember that, an interim goal of water quality that provides for the protection and propagation of fish, shellfish, and wildlife, and provides for recreation in and on the water, be achieved by July 1, 1983. This is known as the fishable, swimmable provision. How many of you have heard of that before? Most of you have, okay, great. So how do we measure biological integrity? Before we can even talk about measuring it, do we understand what it's composed of? This is what it's composed of. And this really isn't everything that goes into it. These are 5 broad categories, including what we've been talking about today: flow regime, chemical variables. There's also biotic factors. There's also how the aquatic ecosystem cycles energy, makes it and uses it, and also habitat. Habitat is a much overlooked variable. I've seen that happen in a lot of initiatives that are taking place today where it's almost completely ignored. But it is as much of a master variable for biological integrity as is hydrology. And the two are, in a way, inseparably linked. So the quality of the resident biota is a direct measure of biological integrity, which is the principal goal of the Clean Water Act. And it's the integration of these 5 factors, and as each is in fact affected by the mosaic of external influences that affects each factor and its component variables. So we have a situation like this. This is an urban stream. Does anybody know where this is? It's in Cincinnati, Ohio. It's Mill Creek. So we have obviously chemical issues. We have physical issues. We have biological issues. And we have energy cycling issues that are the product of the first three. Treating these independently won't solve the problem. And the problem is we do treat them independently. Okay, so what's going to drive this issue are something called water quality standards. So how do we translate clean water act goals into water quality standards? Chemical, physical, and biological integrity. Fishable, swimmable gives us the concept of designated uses. Wherever attainable, we have to analyze the attainability of these uses, or something called a UAA. So aquatic life uses in Ohio. All rivers and streams, named and unnamed, have a legal standing in Ohio through the water quality standards. An aquatic life use is a designation, or essentially a classification, that is assigned to a water body based on the potential aquatic assemblage that can be realistically sustained given the regional reference condition and the level of protection afforded by the applicable criteria. So an aquatic habitat classification of stream generally refers to stream classes in terms of the aquatic biota that is potentially supported. We have warm water habitat that equates to the minimum clean water goal of 101A2. Cold water habitat, we have some of these, not many. Some states have further refined this classification scheme and adopted them into their standards. Ohio has what are called tiered aquatic life uses. This tiered classification scheme includes multiple strata for stream sizes, ecoregions, and the aquatic biota. It is not dependent on any a priori hydrological classification. It is a biotic framework. So specific use tiers are assigned based solely on the biotic potential and available habitat. This scheme is consistent with the federal water quality regulations that were adopted after the passage of the Clean Water Act. Ohio has formalized it with the adoption of tiered uses, biocriteria, and the attendant methodologies for measuring it. Biological criteria are simply a way to express the biology in a measurable format, i.e. the yardstick of the health of a stream. Again, as I said before, they're indexed to reference assemblage with respect to geographic region and other stratifying factors, and they represent a calibrated assessment tool that can foster an organized approach to goal setting in an effort to reconcile human impacts and guide restoration efforts. And they are the arbiter of aquatic life use attainment. They are comprised of indexes. This is the index of biotic integrity. I'm not going to explain it, but what I'm doing, I'm kind of setting up my second talk later on today where I will talk about IBIs. So they do account for natural variation via classification, different types of streams, and across stream and river sizes represented by drainage area within each site class. They have a companion index for invertebrates, so it's a two assemblage approach. And again, the same thing is done to calibrate that. And this is kind of what they look like. They actually appear as a table in the standards, but this is with respect to how they vary by the 5 major level 3 ecoregions across the state. And then the exceptional warm water use applies statewide. So, coming full circle, how to distinguish good from poor, and more importantly, what this sets up is we do have a gradient of measurement all the way from excellent to very poor. And these are just some examples of what a good and a poor would be for each one of the major 5 factors. So the biota reflect and integrate the aggregate effects of the alterations to one or more of these factors. And the biocriteria and the attendant chemical physical tools that accompany it provide the technology to measure it. And I wanted to mention habitat, and this is the habitat indexes used to measure the quality of habitat in Ohio. And a lot of other states have followed suit and adopted this. So like flow, habitat is a master variable that plays a critical role in determining if clean water act minimum goals, that is warm water habitat in Ohio, is attainable in a particular river or stream. It is as important as flow in how pollutants affect important in-stream processes and eventually the biota and the beneficial use of the water. So this is, I found an article written in 1980, and it kind of reflects the attitude that has prevailed through the Clean Water Act about the attainability of Clean Water Act goal uses. And there's a statement in there, through literal interpretation of Section 101A2 of the Act, or through excessive zeal, most states designated their streams as fishable, swimmable. The temerity of those states. Well, that statement was made 43 years ago during the infancy of water quality standards development and implementation. Concerns about the attainability of fishable, swimmable remain today, especially for small urban streams. So that concludes my remarks, and I thank you. Supposed to go here.
So while we're getting set up, I'd like to thank all of our speakers one more time, including Laura, who's remote. We're going to start with a quick little panel motivated by some questions from me, so feel free to jump in. And then I think we're going to open it up to the room for any questions that you have for all of us or individually. Where I'd like to start is just with a general question for everybody. You can either take it as sort of the challenge or the positive side to kind of talk about some what you envision as either one of a major challenge within your focus area for the coming decades, or if you'd rather take the positive side, something that you're really optimistic about with respect to your particular interest for the coming decades with respect to water in Ohio.
Would you like me to start? Am I on?
Yeah, jump in.
Is this on? Can you hear me? Okay, good. Well, I'm going to throw a curveball at you. We have water quality issues, we have water quantity issues, and we also don't have enough water. What? What is she saying? Well, you heard of the development that's happening over in Licking County, Intel. The reality is they need, and all of that development needs a lot of water. And it's an issue to try to figure out how to get them water and get it to them sustainably, get it, accessible. We have the city of Columbus, but, we weren't planning for this type of development for 30 plus years, and here it is now. It's happening now. So I think a big issue that we have is availability of water. And I know we are water rich here, right? We've got the Great Lakes, and we're nowhere near the problems in California. But at the end of the day, what's the cost benefit and what makes sense on getting new development water? And wouldn't it be interesting if we could harness the flood water and use that for development in the future? But that's a thinking way out in the future here. But that could be something that the reality is we've got flooding problems and we've got water, not enough water. So how do we fix that?
I see positives and I see challenges in regard to flood risk management. The positives are we are now seeing more data. We're seeing more action towards what we can do to manage our flood risk. We have technology, we have more data, we have funding resources now that we didn't have previously to implement action. But the challenge is also balancing, the challenge then is also linked in the sense is community buy-in. How do we link all of that data and all of the initiatives to an economic benefit? How do we convince communities to regulate to higher standards? Because in my 20 plus years of working in the floodplain management program and working with communities that regulate floodplain development, one of the things that we see is, as they're doing permitting, as they're reviewing individual projects, most of the time, developers are only going to do what the regulations require them to do. They are not looking, and this is a generalization, but most of the time they are not looking to be very forward-thinking. They're looking at what they're required to do and meeting those requirements, staying on deadlines, working through all of the permits and the requirements that they have to achieve. So how do we get communities to think about sustainability? How do we get them to decide what specific regulations and strategies would be appropriate within their area or region to reduce or offset flood risk? And so those are big conversations, those are tough decisions, and those are big pressures that communities are faced with. And so I think we have to look at these not only on a jurisdictional basis, but on a regional basis to figure out how we leverage the resources that are available to us and leverage partnerships. And I sound like a project management manual right now, leverage. But really gather the resources that are available to us, gather those partnerships, those organizations, entities, agencies that have knowledge, that have data, that can substantiate and validate those decisions that communities can make, that give them the data to base those solid decisions on and give them a reason for regulating to a more stringent standard and protecting development as it moves forward, making good decisions about redevelopment, and continuing to do better each and every step forward. And so when we have the opportunity to change our built environment, what's the best strategy? What's best for our community? What's best for our region? And look at it in a more forward-thinking sense instead of what we're faced with today. So those are the things that I see, but that's a big list. That's a lot. So we just have to start piece by piece and tackle that as best we can, and that's how we make some progress.
So I'll just take a couple seconds, I hope, to say this, but the good news is that the Clean Water Act has been largely a success, and I'll focus on what we call large rivers in Ohio, where in 1980, only 23% were meeting clean water goals, and I'm talking about the biological goals. And as of about 2016, 95% were meeting. So that is something we need to preserve. And the Scioto River downstream of Columbus is probably one of the best of those success stories. But I look at the already ongoing development in the outlying areas, and it's not just Intel. It's Plain City, it's Hilliard, and it's even south of Columbus around Rickenbacker. And there's a lot of land use changes being made. Yes, we have standards, we have stormwater regulations, but I have to be honest with you, the stormwater program is not the equivalent to the NPDES permit program that achieved all that success over the past 50 years. So we've got a lot of work ahead of us to stem, to preserve those gains that we made. That's what worries me the most. And these gains were made against the backdrop of all these hydrological changes that we're talking about. But my question is, what's the tipping point where that's going to be an issue as well?
And Laura, I don't know if you can,
Can you hear me? Am I on?
yeah, that works well, thanks.
It looks like I have the biggest head in the room right now. Anyway, so so my thoughts on this are a little bit different because I'm always coming from the idea of trying to figure out how nutrient loading coming from these different sources are going to be altered, maybe moving into the future. And one of the things that's really intrigued me about some of the sort of looking at future climate scenarios, but then also sort of looking back into certain, cases that we've seen recently is this weather whiplash sort of idea of having really wet springs going into a really dry summer. And I think that could have some really unique and different effects on the formation of things like harmful algal blooms in rivers. Right. So, some of the great example being the Ohio River blooms, but they're also happening all over the place. And this could be, to me, this is a concern because it's taking something that you usually think of as a distal effect or, something that's coming from agriculture that could really have an effect then on our cities and towns sort of throughout Ohio. And it's not unique just to Northwest Ohio. It's, it's happening everywhere. And so to me, I think there's going to be some serious challenges associated with not just whether like water quantity being high versus low, but then those ramifications of altering how nutrients and sediments are being delivered to these ecosystems, which have these sort of cascading effects. Now, luckily, there's a lot of people that are working on this and developing forecasting models for this sort of thing. And I think that there's, in Ohio specifically, there's a lot of attention, at least to dealing with agricultural runoff. And so with the technologies and the advances I see, I always like to try to end a little bit positive. And I think that we'll probably go through some tough times, of course, but I believe that we will be able to have the technology and ultimately, if this is starting to affect things greatly, then hopefully the financial support to be able to implement some of these policies.
Great, thanks. So I think we've got time. I'll do one more question from me, and feel free, if you don't have an answer to it, that's fine. We can open it up. We've got a big group here, so I'm sure there are questions specific. But I just wanted to give you the opportunity to answer. Are there any additional water-related issues for Ohio that maybe you didn't get a chance to talk about, or that you'd just like to amplify here before we open it up to the crowd? And
Well, I mentioned it in my first
yeah,
topic. It doesn't seem like it's an issue, but it's going to be an issue. I mean, they say that the population of Columbus will be 3 million people by 2050. And we've got to make sure that we grow sustainably. If we don't, we're just hurting ourselves. So this room and those frontline influencers, those stormwater managers, those floodplain managers, those county commissioners have the power to influence change and make sure that the development is sustainable and thinks about the resiliency of the watershed. So I think that for us in Ohio is the biggest issue that we have. It's great to be growing, and I'm very proud of Ohio, but I'm concerned about where we're going if we don't do it the right way.
whoever'd like to go, yeah.
Well, I'm going to talk about some of the emerging concerns we have later on, so I won't give that away. But I agree. We are that's a 500,000 population increase. I thought it was by 2030, but yeah. And there's going to be an onrush of this, but I'm going to put my policy hat on. We don't have a lot of friends out there right now for even keeping the current environmental policies we have. There is a great zeal to deregulate. And it's not through direct assaults on the enabling legislation, it is assaulting the implementation of those. And that's been going on for about the past 12 years. So if you aren't aware of it, become aware of it. But there's been some legislation passed in Ohio right now that is requiring the removal of regulatory restrictive language. And it doesn't apply just to Ohio EPA, it's all state agencies. So it's this push to deregulate, we have too many regulations, and so on and so forth. And I think it's just a way to score some policy points to say that they have done something about eliminating and reducing regulations. But, so being careful about how we develop, let's be careful about how we legislate as well, because that's not headed in a very good direction right now.
Laura or Alicia, or we can open it up to the group too.
I will just quickly say, I'd like to echo the sentiment that water conservation is a very important issue moving forward. I know that our division at ODNR, Division of Water Resources, is very concerned, and very, very closely monitoring water conservation efforts and water use moving forward. So that's a very important issue to Ohio moving forward. So that's all I'd like to offer there.
The only thing that I would add to this that I don't think we've brought up as much would just be like, we talk about how it seems like, flows are increasing or stormwater challenges are going to be increasing. But I think that we've had a few years here where understanding the impacts of those, or even going from high flows to low flows, the full impact of that on what we'll actually experience is really hard to predict and understand. And so while we want to be able to be well prepared for whatever new future there could be, I think that we have to come to terms with the idea that it might not go the direction we think it will. I've seen some watershed models that imply that, with increasing nighttime temperatures, we might see lower flows instead of higher flows, although that's not what we've seen yet. But the ramifications of that in terms of, downstream impacts or larger environmental impacts are going to be really hard to predict. And then I also think, because I usually come from more of an agricultural side of things, is, we learned from 2019 that sometimes the weather can be so bad you can't even farm. And then trying to predict that impact is even more difficult. So thinking about if we have bad enough conditions that you can't develop in the same way, what impact is that going to have? So some people might be having to think outside of the box on the full sort of ramifications of everything coming together, especially in terms of that uncertainty. So.
Great, thank you. So now I'd like to open it up. Oh, and it looks like we've already got our first question.
Well, this question's for Chris Yoder. You mentioned the great improvement in water quality in the larger rivers in Ohio. I'm wondering, everything else we've heard this morning for headwater habitat and aquatic biodiversity, are the losses in headwater habitat likely to get kind of worse in light of the climate change we're facing?
Yeah, thanks, Dave. A good question. So the smaller watersheds have not followed the path of large rivers. They have seen an overall increase, but that improvement diminished very rapidly. And so I would say, I think the statistic I recall is about 65% of our smaller watersheds are meeting those goals. And a lot of that is due to the legacy and even existing practices that manipulate those headwaters. And through outright habitat modification, landscape development, encroachment, you name it. And of course, it's been very difficult to convince the forces that want to do that to do it differently, to avoid it, and that type of thing. It's so entrenched in our both agricultural and their urban development practices. So, as you know, we heard before about the concerns about how are we going to handle a 500,000 population increase in central Ohio. That's only going to bring these pressures to bear if we keep doing it the same way we always have. And believe me, there are forces out there who don't want to change the way they've always done it. So that I'm much less optimistic about.
I think we've got another question in the back.
Yeah, I have a question. It's about how regulators are accounting for intensifying river events. So it's kind of a two-part question, and whichever panelist feels most qualified to answer, I'd love to hear it. How are regulations changing around the 10-year, 25-year, 100-year floodplains? And how are we accounting for more intense river events and the development and the safety, public safety associated with that? And then my second piece is so much of our infrastructure is built around those events. A lot of buildings are at the 100-year level or the 25-year level, and even a lot of our overflows are set for specific river levels. How is the work you're doing as floodplain managers coming back to the engineering, design, and infrastructure? And do you see any issues looking ahead on that?
Was that Dante? Okay, I thought so. You heard earlier Alicia say that our flood regulations that we currently have, the NFIP, is really just a guide. We knew even 20 years ago they were at best 70% accurate, and I would hazard a guess that they're even less accurate now. And the issue, we can study all these wonderful watersheds and biodiversity and the water quality. At the end of the day, if we don't have people buying into changing our regulations and looking at more advanced standards, what are we doing? And so, we regulate to the 100-year flood, but we know that a 25-year event or a 10-year event, even a 5-year event, impacts people. So we have to look at different strategies and ways to arm and educate our frontline soldiers, if you will, in this world of trying to figure out how to protect our water resources. And to your point, Dante, I don't know very many communities that are regulating to a much higher standard, especially in urban or rural areas, less than 100-year. So, and we know that those are pretty big storms, but the irony is that they're coming more and more frequently. So how do you get them to buy into the fact that this is something that they should be looking at closely? And I'm going to put a plug out. Our next session after we're done here is we want to create a subcommittee through the Ohio Stormwater Association to arm those people, those folks that are trying to help regulate their communities, and give them information. Give them as much information as they can to help create that balance of understanding how regulations can help them, but also not hurting urban or economic development. There is a balance, and so that's what I think as practitioners we need to show. I don't know if I answered your question, Dante. Maybe part of it. Okay. Did anyone else want to talk about floodplains, Alicia?
So you heard me speak about higher standards, and the reason why I mentioned that is that communities regulate flood hazard areas that are depicted on FEMA floodplain maps according to a jurisdictional basis. So they adopt the minimum standards to the minimum federal criteria as the basis for their participation in that national flood insurance program. The reason they do that is so that federal flood insurance and disaster assistance are available within their communities. And so they adopt these floodplain regulations, and they are required to administer a floodplain permitting process. Now, it's also within their ability to adopt standards that exceed those minimum federal criteria, because they're the same criteria that apply in Ohio, that apply in California, that apply in Louisiana, Florida, the Carolinas, et cetera. So that's the baseline for communities to adopt. Now, Ohio is a minimum NFIP state, so we don't have higher state standards, and some states do. So as a state, Ohio just adheres to the minimum NFIP standards. So that's why it's important for communities to look at their own individual flood risk and what those risks what those risks include, so that they can adopt regulations to address that specifically. So, for example, you may want to regulate to the 0.2% annual chance floodplain or the 500-year floodplain. You may want, or community may want to adopt compensatory storage standards, where if they're putting development in the flood hazard area, they're compensating for that in some way. They may want to elevate development to a higher level. They may want to protect access or egress, or they may want to limit development along specific water courses or channels. They may want to prohibit residential development in a high-risk area. So there are many strategies that communities can implement on a local basis to reduce their localized flood risk, but that's only within their jurisdictional boundaries. And so that's why I encourage communities to really look at a regional level to, basically what makes sense for their region, what makes sense for your watershed, how can you reduce flood risk as a whole, and overall, in the long term, talk about sustainability, and that's going to be an asset to your economic development. So
in the interest of time, I'd like to thank our panelists once again. So thank you. I know there are probably a lot more questions, and we're all passionate and can probably talk all day. So please grab us with your individual questions if you've got them.
Wonderful. Thank you, Jim, Kari, Alicia, Chris, and Lara as well for your remarks and participation today. I think we had great attendance here. I think so much interest that even the geese were trying to come join us here at the end. But that was interesting. I hadn't experienced that here before. As is our EPA tradition, we want to recognize you with a certificate of appreciation and thanks for your contributions to our community today. I'll note, Lara, we have one that we'll be sending up to Heidelberg today for you as well. So thank you for making it work to join us virtually as well. This was a wonderful panel. I'm so grateful for the conversation that's been had here today. I think, just thinking through what stuck out to me, I think the idea of the importance of these long-term and continuous ongoing observations, but also the complexity of these decisions at the local level, in many cases, maybe linking together areas or sectors that haven't traditionally communicated or been thought of as being connected, and really thinking of the complexity of these choices at the local level. I'm grateful for the speakers that brought this broad range of expertise here, as well as in the ongoing discussions we'll have today to help work through these complex discussions. We have an excellent in-person programming continuing right here in this room afterwards. After we wrap up here, please refer to the agenda in your program for details about that. As you can see, there are many experts here in the room in a variety of areas that I encourage you to interact with and network with to learn more from throughout this morning. Before we take just a 15-minute break, I want to encourage you to learn more about our upcoming EPN events, including a very special Earth Day event that is in the works. Please register today for our signature Earth Day event taking place on Wednesday, April 19th. I'm at the Fawcett Center here at Ohio State. For this evening program, we will host an end-of-year networking reception with graduating seniors, environmental professionals, and then transition into an immersive experience created by Orlando Hunter and Ricardo Valentine of Brotherhood Dance. who will debut with us their Black on Earth multimodal gallery installation and dance performance. This program will center rich eco-memories of Black people on land. The work highlights the 20th century Pigford versus Glickman case, setting a historical foundation for the struggle toward land sovereignty in America. Dr. Tiffany Bourgeois, a professor of arts management, will join with Jara Oliver and Adrienne Williams, co-founders of the Growing and Growth Collective, in a conversation about blending the arts, agriculture, and community using culturally relevant and evidence-based programming. Dr. Ramiro Berardo, who many of you met when we released his film And Water for All at this very forum 1 year ago, has created a brief program teaser for us to view today. So we'll watch that now briefly.
Delaware, Sikula Jiribo, Kando Sanyam Baria, oh, Sankan Wewe Saramore, oh, Anifan Delaware, Sikula Jiribo, Kando Sanyam Baria, oh, Sankan Wewe Saramore. Delaware, Sikula Jiribo, Kando Sanyam Baria, oh, Sanka Wewe Saramore, oh, Anifan Delaware, Sikula Jiribo, Kando Sanyam Baria, oh, Sanka Wewe Saramore. Delaware, Sikula Jiribo, Kando Sanyam Baria, oh.
This will truly be a signature Earth Day event, and we encourage you to join us that evening through in-person or live virtual participation options. Last, please plan ahead for Monday, June 5th, which will be a celebration of 4 outstanding environmental professionals and champions, including Dorothy Teeter, Rick Queen, John Gherkin, and John O'Meara, into the Honorary 100 Society, and will feature a field tour of one of our university's landmark research sites, the Waterman Farm, to observe internationally recognized agricultural and ecological restoration sites. If you join the EPN today, which is free, quick, and easy, then you will receive updates on events and program opportunities. Visit epn.osu.edu to join today or connect with Joe and Kalia directly to become a member. Thank you again. I'm excited for the remainder of our presentations occurring throughout the remainder of this morning. Thank you.
I know.